a bad idea here because we would lose the quadratic term altogether. It would become 0. So we want to make sure also, because I'm going to round this thing to a couple decimal places, but the computer's not, or calculator, like a computer, my answers may vary slightly with what we get out of the model because of the rounding error. You know, so we've seen this before, right? Okay. Take a look at y equals. Notice it is now in y1. And it's in there with more than 4 decimal places, right? So when I hit the graph button, I should see some nice curve go right through the data, like that. As a matter of fact, that's a very nice fit. It's almost perfect. It hits every data point. It looks like I would expect this to be a very good model for this data. In other words, now that I have an algebraic setup for this, I can use that to answer a variety of questions and feel fairly confident that my answer will match up pretty good. Okay, so what are the questions I ask? All right, question A was to use the calculator to get the scatter plot. There we go. And then what type of relationship may exist between the two variables? We discussed this. It's definitely not linear. That's the only other one we've talked about. I don't know how else to say it other than it looks quadratic to me. And you had that library of functions section in here where we talked about the behavior of different functions. I don't think it's a big stretch for me to assume that you can see that as an upside down parabola, or a parabola that opens downward, if you will. Okay, so the choice here is pretty clear to be quadratic. So how would you answer this question? I would probably on the test ask you what type of regression you think was best, and what is your model for that. This is where you write this is your answer. You would say the behavior of the data appears to be quadratic, so here's the quadratic model that I would use. Something to that effect anyways. Okay. So you will get this numbers right here from 2 places. You can either look straight at them in y equals since you have them in there. Go to your y equals, there it is. Notice it says it with more decimal places, and there's the x squared here, and then the x here. Or you can actually go and look where you ran the quadratic regression. There's the a, b, and c value right there. You see them? So the information is available to you in a couple different places. All right. Now we want to determine the distance that maximizes the height. So if we take a look back at the graph. We're not seeing the entire trip here. We're seeing it go from here up and sort of come back down. We might be interested in looking at the entire behavior of this model now, because a ball that's been launched from the ground will go up to a maximum height and eventually come back down, right? So we should probably do that. But we have the ability to see the maximum already, so let's leave it alone for just a second. Now, what's the question I have for you guys? If I had to estimate the maximum height here, what's one way to do it?
Second calculator.
That is one way to do it. If you go to your second calculate button, it has a maximum finder. Then we're going to do it that way. But before we use the calculator to do that, what is another way to do this?
Can't remove the dot maneuver, should I say?
Okay, let's go away from the calculator and just have a quadratic here. What's another way to do it using the function? I was hoping somebody would remember an entire test we took about finding the vertex of a parabola. What is the formula for finding the vertex of a parabola? Minus b over 2a. And then f of that number. Remember doing this like 5,000 times? Okay, and the reason I did it so many times is so that when I asked you again in the future, you would say, sure, you find it by saying, well, clearly we didn't do it enough. So 5,001. We take the middle term, negative middle term minus twice the first term, and we'll get the vertex point. Notice the question said, find the value of x that maximizes the function. So all I need to do here is take minus 1.0435 and divide it by 2 times negative 0.0038. Of course, I'm using 4 digits. The calculator's got a graph using 9 digits. So my maximizer may be off slightly than theirs, but it'll be close, okay? So take your calculator right now and do minus 1.0435 divided by 2 times negative 0.0038. I'll do the same. 137. Did you guys get the same number? Okay. So according to the hand, or doing it by hand without, well, I sort of did it by hand. I put the values together by hand, but I ended up using the calculator to do that, the calculation. So I'm using the calculator anyways, but according to that work, I got 137.3. Now we can also do this using the maximum finder by the calculator. So what you do here is you get second, first of all, I'll get back to the graph. Second, calculate, and option number 4 is the maximum. Now this is where you have to answer a series of questions. We've done this before. This time though you actually have to answer them. You can't just hit enter a few times. We need to be somewhere to the left of what appears to be the top. Mine is. So since my cursor is blinking somewhere to the left, this is indeed a left bound for the what appears to be the maximum. So I can hit yes on this or enter. And now it's asking me for a right bound. Now I'm clearly not to the right, so I need to move this cursor until it's somewhere. And it doesn't have to be equidistant or anything, just anywhere to the right of what appears to be the maximum. Right there, I'm clearly to the right. Do you agree? Okay. And then the last question is go guess somewhere. The guess isn't really that important, just somewhere close. 138.03. For lack of better purpose, I'll just call it 132. Okay. That is not exactly the same thing I got, but it's within, it's actually 0.7 something away. What's the deal? Why is this one different than mine again?
Rounding.
Yeah, because I used 4 decimals and they used 9. So theirs is probably a little bit more accurate. And you could almost say significantly, that's about 0.7 of a foot difference. In some cases, that's enough to be significant, right? In other cases, not so much. So depending on the context of what we're trying to model, it will dictate how accurate we want to be to the model. And again, this is a model, so there's no reason why mine couldn't be more accurate over theirs. You would expect to see this behavior by cutting some decimal places off. Okay. So for Thursday, you'll have data. You will model it with whatever particular function you think is best. And then I'm going to ask you a question like this. What is the value when x equals to something? Or perhaps I'll ask you another question like this next one, which is predict the distance, or predict the height of the distance is 110 feet. How do you do that?
Second top value.
Yes, exactly right. Go ahead and put it. You can do second, calculate the value at 110. And you'll get 74.35. Which, by the way, makes a lot of sense because at 138 feet we have the maximum height of 77. Let me notice that. Okay. All right, now there is another way to do this, by the way, without using the graph, and you should probably see this one time. Under the variables, y variables, y1, what's sitting in y1 right now? Our quadratic equation. And we want to evaluate that quadratic equation for a particular x. Instead of going to the graphic thing, if you just put it in parentheses, just like you would on a piece of paper, right? That says to evaluate the function at this point, you should get the same answer. Under variables, go to y variables function. And then choose option. You see y1? And then put in parentheses whatever value. Something nice about this way of doing things is the window doesn't have to fit